Hello everyone and welcome to Physical Science. Today we are going to be talking about the specific type of waves called electromagnetic radiation. So let's go through. Okay, the first type of radiation we are going to be, first of all let's talk about electromagnetic radiation in general. So these are going to be created by the motion of electrically charged particles. Do you remember how particles can be charged? These are the charged particles moving around, so created by the motion of electrically charged particles. So the waves and sound and all of the other waves we've been talking about have required a medium to travel through. Well, electromagnetic waves are the first one that do not require a medium. They can travel through the vacuum of space. So in one of the units we talked about how in space no one can hear you scream because there is no medium. Well, electromagnetic radiation can travel through the vacuum of space. So the speed of electromagnetic radiation in a vacuum is 3 × 10⁸ meters per second. So, speed of light. So electric and magnetic components are perpendicular. So the electric and magnetic will be up and down perpendicular to one another as opposed to parallel to one another. So here's our EM spectrum. So this is the spectrum of all electromagnetic waves, and they go from the least energetic, which are the long, slow waves, to the most energetic, which are the fast waves, the ones that are high frequency. So the best way to remember what's going on with this particular thing is the 3 L's and shh. Okay, so let's look at 3 L's. Long wavelength. 3 L's. Low frequency, low energy. So if we draw a line in our notes of the electromagnetic spectrum, the ones that are longer wavelengths are the ones that are like this. Okay, so they're long, low, and low, the 3 L's. Long, well, even like you can see that a long wavelength gives you a low frequency and it's not very energetic. So the ones on the opposite end are going to be shh. So right, shh, short wavelength, high frequency, high energy. So this is our short wavelengths. So they look like this. Okay, as opposed to these over here. You can even see that the short wavelengths are more energetic. So when you are looking at the electromagnetic spectrum, which you will be provided with on your reference table, you can tell that the ones down here on the spectrum, which are longer wavelengths, will have low energy because they're low and slow. These, however, short is high frequency and high energy. So out of all of these different wavelengths, radio waves would have the longest wavelengths and the lowest frequency, which is the lowest energy, and gamma rays would be the shortest frequency, shortest wavelength, highest frequency, and highest energy. And then we have visible light here in the middle that makes up what you can see. Now all of these you can't see, all of these you can't see. So the only electromagnetic radiation you can see is in the center here in the visible range. Roy G. Biv. So the first type we're going to talk about is radio waves. Longest waves, and they are for communication. So just longest and for communication. So these are way down low, and they're going to be very long, slow waves. So radio waves are slow and low. The second type of waves on the spectrum is microwaves. So we're getting a little bit faster. These penetrate food and vibrate. So water and fat. So they're pretty much putting charged particles into your food, and when you put those charged particles into their food, your water molecules start doing this. And as we know, motion is heat. So as those water molecules start speeding up, it heats up your chicken. All right, this is going to create thermal energy. So microwaves penetrate things and just cause the molecules to vibrate, causing them to get warmer because vibration is heat. The third type, going from longest to shortest is the infrared. These are slightly lower than visible light. So they're just a light slightly lower than what we can actually see. If you use an infrared camera, what you'll see is it actually creates an image of the waves that are slightly longer than visible light. Some animals can actually sense some of this. So this can raise the thermal energy of objects. So if you're looking at infrared, what you're really looking at is heat waves, infrared heat. So you can see here that you have a warm area of the house and a cool area of the house. So we're going to increase to a faster wavelength. This is visible light. So 4 is visible light. This is spectrum we can see. Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. And they are still in the same order of longest to most energetic. Violet would be the most energetic. So these are in order of decreasing wavelength. Red is the longest wavelength. So if I were to write, and I would recommend you do, Roy G. Biv in my notes, red would be a longer wavelength, and then we're increasing, and then we're really, really high. So this is the longest wavelength, the lowest, the slowest, and this is the shortest wavelength, and this is going to be super high energy. So the most high energy wave that we can actually see is violet color. The next type, which is faster and shorter than our visible light, is the ultraviolet radiation, UV. You can't see it, but it's there. You can tell when you go to the beach and you get sunburned. So slightly higher than visible light on the spectrum, and they cause skin damage. You can't see that it's there. You can feel that it's there though, and it is slightly shorter than what you would see as visible light. Then we have X-rays, like X-ray vision. So this is higher energy than UV, so we're increasing in energy as we go. So higher than UV, and it can penetrate soft tissue but not bones. So penetrates soft tissues, not bones. This is why when you get an X-ray, you can see just the bones are left behind, because they will go through the soft tissues and will bounce back off of the bone. So when it bounces back, it creates this image. The waves that are going through the soft tissue are not bounced back, which is why we don't see them. So this is used for doctors and dentists and things to see bone structures. And the highest one is gamma rays. So these are the ones that are supposed to like cause crazy mutations and turn you into the Incredible Hulk. Chances are it would just kill you, so lots of gamma radiation, not good. This is the highest energy. That means it is going to vibrate like crazy in your body. So this is the shortest wavelength. We're talking like, and this is used to kill cancer cells, but it can also kill all of your cells. So that's why I say if you were exposed, so this is a treatment where they just pinpoint the one cancerous area and they try to kill the cells in that one area. If they were not to pinpoint it over just the area that they need to treat, then they would pretty much be causing the rest of your cells to die. So yeah, gamma radiation causes cell death. So that's not a good thing. It won't turn you into the Incredible Hulk, so I would not give that a try. Okay, let's focus a little bit more on primary colors and light. So the primary colors are red, green, and blue. And when you combine all of them together, you get white light. So white is actually all colors together, and black is the absence of all colors. So these combine to make white light. So when white light comes in, you can actually take a spectrum or a prism, excuse me, and when the light hits the prism, it separates it out into wavelengths. So you would see a rainbow. So it takes all of the colors in the white light and separates them out. Kind of looks like a Pink Floyd album going on right here. All right. Now, seeing colors is only possible because of cells in your eyes. So the retina contains, so the retina of your eye, it's the center portion of your eye, right there. And at the back of your eye are all of these nerves, and they send signals directly to your brain. Well, rods detect dim light and black and white. So if you had just rods, you would be entirely colorblind. You could see black and white, but you would not be able to see, color. So if you want to know, okay, well, how do we know if animals can see color or in black and white? Well, you can see rods versus cones, so it's not like they can go up and ask the animal, hey, do you see black and white or do you see color? They can actually dissect eyes and look at rods versus cones. The cones are what detect color. So anything that sees nothing but black and white would be seeing in nothing but rods, and cones are going to be for color. So that's why you see all of these beautiful colors. And yeah, all right, everyone. I hope you enjoyed, and I hope you have a splendiferous day.